Like in the last class, as we are discussing about this compounding of plastics, in that we have, okay, what are the compounding of plastics? Plastics is nothing but the process of adding the chemical admixes, okay, additives to the uh, resins, okay, to increase the physical properties of molded products is called as a compounding of plastics. Compounding of plastics, there are these are the following additives we need to discuss in order to get the the resin. The following are the important additives added to the polymer resin. First one is resin. The major portion of the plastic Okay, these are the additives we are adding to the polymer resin. Now coming to the first one, already we have discussed this. What is the use of this resin is? It is a resin is the binder or polymer material which constitutes the major portion of the plastic. Okay, again, resins are of two types. Already we know this: thermoplastic resin and thermosetting resin. Thermoplastic is the nothing but the one form of resin which is fusible and remoldable. Okay, we can remold this thermoplastic resin. Okay, which is fusible. We can convert this thermoplastic. Okay, thermoplastic resins are in between the polymer chains. It holds a weak van der Waals forces are present. Okay, it undergo easily the breakage. So here the hard rubber can get converted into the soft rubber on heating, and on this soft rubber on cooling, it gets converted into the again it reappears. It converts into the hard rubber. Okay, we can remolded this thermoplastic resins, but we cannot molded this thermosetting plastics. Okay, here it is non-fusible. Okay, cross-linked non-fusible form of resin is known as thermosetting plastic. Thermosetting plastic, which required catalyst during the molding process. It requires catalyst during the molding process. Next, coming to the plasticizers, which increase the flexibility and plasticity of the resins. Okay, here the chemicals, plasticizers are nothing but the chemicals that are added to the resin to increase their plasticity and the flexibility of the plastics. Okay, these are the chemicals that are added to the resin. Resin is nothing but major portion of the plastic is a resin. Okay, major portion of the plastic, major portion of the plastic is the resin. Okay, we are adding this to the okay, plasticizers are the chemicals. These are nothing but the chemicals that are added to the resin to increase the plasticity and flexibility. Here, inside the polymer chain, these plasticizer molecules get inside the polymer chain and neutralize the intermolecular forces. Okay, it will neutralize the whatever the forces that present between the chains, polymer chains between the micromolecular polymer chains. It will neutralize these plasticizers will neutralize the intermolecular forces present between the forces of attraction between the micromolecular polymer chains. Then breakage, it helps to this plastic helps to break the intermolecular forces between the polymer chains and facilitate the greater freedom of momentum of polymer chains, thereby increasing the flexibility of the plastic. Okay, thereby increasing the flexibility of the plastic. On increasing the flexibility of the plastic by addition of plasticizers, reduces the strength and chemical resistance of the plastic. Okay, on this adding these chemicals, okay, plasticizers, okay, it helps to the addition of reduce the strength and chemical resistance. Okay, length and chemical resistance has been reduces due to the flexibility of the plastic. Okay, the most commonly used plasticizers are nothing but chemicals or vegetable oils, tricrysyl phosphate, tributyl phosphate, and triphenyl phosphate. Okay, these are the chemicals that are added to the resins to increase their plasticity and flexibility of the plastic. Plasticity and flexibility of the plastics. Example: vegetable oils, tricrysyl phosphate, tributyl phosphate, triphenyl phosphate. Okay, these are the acts as a plasticizers. Okay, tricrysyl phosphate, the structure of tricrysyl phosphate, tributyl phosphate. Okay, here it helps, this plasticizer helps to break the intermolecular attractions present between the polymer chains, and it helps to the facilitate the strength of the plastics. Okay, flexibility and plasticity of the plastics. Now coming to the third type, that is fillers. Okay, fillers are the materials added to the molded mixture. Okay, here these are the materials that are added to the molding mixture in order to give their better hardness, strength, okay, opacity and workability to the plastics. Gives the better hardness, strength, and okay, fillers are the materials added to molding mixture. Okay, molding mixture in order to give their better strength, okay, hardness to the plastic, workability to the plastic. Here the fillers reduce the cost of polymer, and also reduces the brittleness of the polymer. Okay, some special properties exhibited by fillers are given below. Here, carborundum. Example: carborundum, quasar, and mica are added to provide the extra hardness to the plastics. Okay, example: the carborundum. This is the act as a filler. It gives the it provides the hardness to the plastics. Okay, quasar and mica, okay, are added to provide the extra hardness to the plastic. And barium salts, barium sulfate. Example: barium sulfate is added to the plastic to impervious the to X-rays. Okay, impervious to X-rays. Addition of asbestos. Addition of asbestos provide the heat and corrosion resistance to the plastic. Okay, addition of asbestos provides the heat and corrosion resistance, and the percentage of filler is up to 50% of total molding mixture. Okay, here 50% of the fillers are to be present in the molding mixture. Most commonly used fillers are wood floors, gypsum, sawdust. Here in the picture it is given marble floor, cotton fibers. Okay, this acts as a fillers. Okay, they are added to molding mixture in order to give them better hardness, strength, and workability to the plastics. Example: carborundum, quasar, and mica are added to the provide extra hardness to the plastics. Okay, it gives the extra hardness to the plastics. And barium salt, okay, barium sulfate is added to make the plastic impervious to the X-rays. And addition of asbestos provides the heat and corrosion resistance. And most commonly used fillers are wood floor and gypsum, sawdust, marble floor, cotton fibers, etc. It acts as a fillers. Next, coming to the lubricants. What actually the lubricants are? Okay, lubricants are makes the molding of plastic easier. Okay, what the use of this lubricants is? It makes the molding of plastic easier. Molding of plastics easier. Lubricants makes the molding of plastic easier. They impart glossy finish. Okay, glossy finish to the products. Okay, it gives the glossy finish to the products. Lubricants prevent the molded article from sticking to fabrication equipment. Okay, lubricant prevent the molded article from sticking to fabrication equipment. Example: waxes, oils, stearates, soaps, etc. are used as a lubricants. Okay, it gives a molding of plastics easier. They impart a glossy finish to the product. Lubricants prevent a molded article from sticking to fabrication equipment. Example: waxes, oils, stearates, and soaps are the examples for the lubricants. Now coming to the accelerators or catalysts. Okay, what is the use of these accelerators or the catalyst? Okay, catalysts are the mainly added to thermosetting plastics. Okay, not for the thermoplastics. Okay, thermoplastic resins. These are added to thermosetting plastic in order to accelerate the polymerization of fusible resin to cross-linked form during the molding operation. Okay, the accelerators or catalysts are added to the thermosetting plastics. Okay, thermosetting plastic, because there it has a three-dimensional network. Okay, and we cannot convert this three-dimensional plastic thermosetting plastic into the soft form. It itself is a harder in nature. Okay, thermosetting plastics are yeah, these accelerators or catalyst added to the
Sir, your voice is breaking.
setting plastic
What is
uh,
breaking?
in order to
Sir, your net is very poor.
accelerate. What's the use of this catalyst is adding to add mainly to the thermosetting plastics in order to accelerate. Okay, add thermosetting plastics to in order to accelerate the polymerization of fusible resin to cross-linked form during the molding operation. The catalyst used in this process hydrogen peroxide H2O2, H2O2 and benzyl peroxide, metals like copper, lead, oxide, zinc oxide. Okay, hydrogen peroxide, zinc oxide. Here it acts as a catalyst. It converts the thermosetting plastics into to cross during the operation. Next to stabilizers. Stabilizers are the added to components. They are added to molding components to improve the thermal stability of plastic during the processing. To improve the thermal stability of the plastics during the processing. There are two kinds of stabilizers. One is called stabilizers and transparent of good type and like
Sir, your voice is breaking, sir.
morning. It's breaking. I have changed my network. Wait. Okay, sorry, there is a network issue. Ma. Stabilizers added to molding components to improve thermal stability of the plastic during the processing. Molding are the stabilizers. Okay, the stabilizers may be lead salts like chromate, white lead. Okay, white lead, lead silicate, etc. are used in the opaque molding, and in transparent molding stabilizers, stearates of lead, barium, okay, barium stearate and cadmium are used as a transparent molding stabilizers. Okay, here opaque molding stabilizers are white lead, silicate, etc. This is the opaque molding. States of lead, barium, cadmium are used in the transparent molding. Okay, there are these are of two types. Stabilizers are of two types. One is opaque molding stabilizers and transparent molding stabilizers. Okay, these are added to improve the stability of the plastic during the processing. The last one is colorants. Okay, coloring agents that are added to molding mixture. Okay, molded mixture which gives the desired color to the plastics. Okay, by adding these coloring agents to the molding mixture, it gives the desired color to the plastics. Okay, there are inorganic coloring pigments as well as coloring organic coloring dyes. Dyes are nothing but colors. Okay, there are two types, inorganic and organic. Inorganic and organic coloring dyes. Coming to the inorganic pigments like lead, yellow color, okay, and iron ferrocyanide dyes, blue color, and aluminum silicate. Okay, these all are inorganic pigments. And organic coloring includes dyes includes cyanin. Okay, cyanin dyes which is in blue to green color, etc. Okay, these are the inorganic and organic dyes used as a coloring agents to molding mixture, which gives a desired color to the plastics. Desired color to the plastic. Okay, there are inorganic coloring pigments as well as organic coloring pigments. Inorganic includes lead chromate, yellow color, iron ferro, cyanin, and aluminum silicate. And organic include cyanin dyes. Cyanin dyes is blue to green color, which is blue to green color. These are the different additives to the resin to give the desired form to the plastic. Okay, one is resin, which forms a major portion of the plastic. As described earlier, these are the two kinds. Resins are of two types. One is fusible and non-fusible form. Fusible form is nothing but thermoplastic, and non-fusible form of the resin is known as thermosetting resin. Okay, which required catalyst during the molding process. Okay, catalyst already we have discussed in the accelerators or catalyst. Okay, these catalysts are mainly added to thermosetting plastics. Okay, in order to accelerate or act as a catalyst the polymerization of fusible resin to cross-linked forms during the molding operation. Okay, the main use of this catalyst, we are adding this catalyst to the thermosetting plastics in order to accelerate the polymerization of fusible resin to cross-linked resin during the molding operation. The catalyst used are hydrogen peroxide, formula for hydrogen, and benzyl peroxide, metals like silver, copper, and lead, metal oxides like zinc, oxide, etc. as a accelerators or catalysts, okay, during the compounding of plastics. Okay, this is about compounding of plastics, okay, which gives a desired form. Okay, the process of chemical admixtures, chemical admixtures, which gives increase the physical properties of molded products, is called compounding of plastics. Okay, compounding of plastics is nothing but it gives the desired form to the proper forms to the plastics. Okay, for application of additives, but many of plastics like phenol, amino resins, and cellulose resins are required additives to mold into their proper forms. Okay, this is nothing but compounding of plastics. Okay, compounding of plastics is a process of adding chemical admixtures which increase the physical properties of molded products. Physical properties of molded products is called compounding of plastics. Compounding of plastics. There are following important additives added to the polymer resin. Resin which forms a major portion of the plastic is size, which increases the flexibility and plasticity of the plastic, is nothing but plasticizers, feelers, okay, feelers, stabilizers, lubricants, okay, which oils added, and accelerated catalyst here, thermosetting plastics, in the thermosetting plastics to convert the fusible into the okay, we are adding this accelerators of the catalyst and the coloring materials. Finally, again, these are of two types, inorganic and organic coloring materials. Okay, coloring materials that are added to the molded mixture, which gives the desired color to the plastics. They are organic coloring pigments as well as inorganic coloring dyes. Inorganic pigments like lead chromate, lead ferrocyanine, aluminum silicate, lead chromate, lead iron ferrocyanine, and lead aluminum silicate. Organic coloring includes phthalocyanine dyes, which is blue to green in color. Which is blue to green in color. Now coming to the preparations of the yeah. Okay, now next we have the preparation properties and applications of PVC, polyvinyl chloride, nylon 66, Teflon, and bakelite. To prepare, and what are the properties and what are the applications of these polymers. Now coming to the first polymer, that is PVC, okay, polyvinyl chloride. We are going to prepare this polyvinyl chloride. Polyvinyl chloride, okay, preparation of polyvinyl chloride. Here PVC, polyvinyl chloride, is obtained by heating the vinyl chloride. Heating the vinyl chloride in presence of small amount of benzyl peroxide. Okay, on benzyl peroxide or hydrogen peroxide, H2O2, in an autoclave under pressure. Here, how we are going to prepare this polyvinyl chloride, PVC, is obtained by heating the vinyl chloride. The formula for the Okay, PVC is obtained by heating the vinyl chloride in presence of small amount of benzyl peroxide or hydrogen peroxide in an autoclave under pressure. Okay, what is the monomer involved in the preparation of PVC is vinyl chloride. How we are going to obtain vinyl chloride is, here vinyl chloride is prepared by heating the acetylene. Okay, the formula for acetylene is CH triple bond CH, okay, in the presence of HCl, in the presence of hydrochloric acid, okay, in the presence of catalyst ZnCl2 zinc chloride, as a catalyst it gives the vinyl chloride. Okay, vinyl chloride formula is H double bond CH and HCl. This is the formula. Okay, formula for vinyl chloride. This is the monomer involved in the preparation of PVC, polyvinyl chloride. PVC, polyvinyl chloride. Here vinyl chloride is obtained by, okay, treating the acetylene with hydrochloric acid at 60 to 80 degrees. Okay, in presence of metal chloride, that is zinc chloride, as a catalyst is called vinyl chloride. This acts as a monomer. Okay, these on, okay, this in the presence of vineling, okay, H2O2, it gives the polymer, that is polyvinyl chloride. Vinyl chloride is obtained by, okay, acetylene treating with HCl in presence of zinc chloride, ZnCl2, as a catalyst it produces the vinyl chloride. Vinyl chloride, it is a monomer. Here we are using this, we are going to use as a monomer. Okay, this polyvinyl chloride is obtained by heating the vinyl chloride in presence of small amount of hydrogen peroxide. Okay, in an autoclave. Autoclave is nothing but catalyst in the presence of heating under pressure produces the polyvinyl chloride. This vinyl chloride we got from the acetylene reacts with hydrochloric acid at 60 to 90 degrees, 60 to 80 degrees in presence of metal chloride, that is zinc chloride, as a catalyst is called vinyl chloride. Vinyl chloride on hydrogen peroxide. Vinyl chloride, heating the vinyl chloride in presence of benzyl peroxide or hydrogen peroxide in an autoclave under pressure produces the polyvinyl chloride. Coming to the property of PVC, vinyl chloride is, okay, it is a colorless, okay, odorless and non-inflammable. Okay, non-inflammable and chemically inert powder. Okay, this is chemically inert powder. PVC is the colorless, odorless, non-inflammable and chemically inert powder, and it is resistant to light atmospheric oxygen. Okay, resistance to light and atmospheric oxygen, inorganic acids and alkalis, but soluble in hot chlorinated hydrocarbons. Such as ethyl chloride. Okay, it is resistant to light atmospheric oxygen, inorganic acids and alkalis, but soluble in hot chlorinated hydrocarbons such as ethyl chloride. So who is this Johnny? I am removing who is starting. I am just okay. Properties. Okay, it is resistance to light atmospheric oxygen and inorganic acids and alkalis, but soluble in hot chlorinated hydrocarbons such as ethyl chloride. Okay, ethyl chloride formula is C2H5Cl. And the melting point of this PVC is 145 degrees centigrades. Okay, here the melting point of PVC, polyvinyl chloride, is 148 degrees centigrade. It is a strong and brittle in nature. Okay, strong and brittle in nature, and this PVC is not stable to heat and UV radiation. Polyvinyl chloride is not stable to heat and UV radiation. It undergoes degradation. It undergoes degradation. Coming to the applications of PVC. Coming to the applications of PVC, here it is a PVC is a rigid and unplasticized. Okay, rigid PVC is the unplasticized PVC have superior chemical resistance. Okay, here the PVCs are of two types: plasticized PVC and unplasticized PVCs. Unplasticized PVCs have superior chemical resistance and high rigidity, but it is brittle and it is used for making sheets. Applications of PVCs, it is used for making sheets, used in the tank linings, safety helmets, refrigerators, components, tires, etc. Okay, these rigid PVCs, okay, rigid PVC or unplasticized PVCs have superior chemical resistance and high rigidity, but it is brittle in nature. These rigid PVCs are used in making sheets, used in tank linings, okay, safety elements and refrigerator components, tires, etc. Okay, these rigid PVCs or unplasticized PVCs are used in tank linings, safety elements, refrigerator components, tires, etc. Now coming to the plasticized PVCs. Okay, it is obtained by adding the plasticizers such as dibutyl phthalate and triglycerol phosphate. Okay, these plasticized PVCs are obtained by adding the plasticizers such as dibutyl phthalate and triglycerol phosphate. It is used for making sheets. It is also used for making sheets. Okay, and in preparation of raincoats. Okay, packing raincoats, tablecloth, curtains, and electrical cables, toys, radio components, plastic coated cloth, chemical components, chemical containers, thermal insulating foam. Okay, it is used in building and cinemas, aircrafts. These are the applications of plasticized PVCs. Okay, plasticized PVCs are obtained by adding plasticizers such as dibutyl phthalate and triglycerol phosphate. It is used for making sheets, packing raincoats, tablecloth curtains, electrical cables, toys, radio components, okay, plastic coated cloth, chemical containers, thermal insulating foam, and that is used in building, cinemas and aircrafts. This is about the preparation, properties and applications of polyvinyl chloride. Polyvinyl chloride is prepared by, okay, PVC is obtained by heating the vinyl chloride in presence of small amount of benzyl peroxide or hydrogen peroxide in an autoclave under pressure. Heating under pressure gives the polyvinyl chloride, that is a polymer. Okay, how we are going to prepare this monomer is vinyl chloride is prepared by treating acetylene with hydrochloric acid at 60 to 80 degrees in presence of metal chloride, zinc chloride as a catalyst. Okay, zinc chloride, acetylene is in the presence of HCl. Okay, here the catalyst we are using is zinc chloride. Zinc chloride as a catalyst produces vinyl chloride. Vinyl chloride in the presence of H2O2 gives the polyvinyl chloride. Polyvinyl chloride, it is used as a polymer. This is used as a polymer. These are the properties. Okay, PVC is the colorless, odorless, and non-inflammable and chemically inert powder, and it is resistant to light and atmospheric oxygen, inorganic acids, alkalis, but soluble in hot chlorinated hydrocarbons such as ethyl chloride. Here the melting point of this one is PVC is 148 degrees centigrade. It is a strong and brittle, not stable to heat and UV radiations. It undergoes degradation. Coming to the applications, there are two types, plasticized PVCs and unplasticized PVCs. Okay, plasticized means, okay, by adding plasticizers, you will get the, okay, by adding the plasticizers such as dibutyl phthalate and triclosyl phosphate, it is used in making sheets, packing raincoats, tablecloth, cottons, okay, and electrical cables like and toys, radio components, plastic coated cloth, chemical containers, thermal insulating foam that is used in buildings, cinemas and aircrafts. Okay, this is about preparation, properties and applications of PVC. PVC is heating in terms of benzyl peroxide, hydrogen peroxide in an autoclave under pressure produces the polyvinyl chloride. Polyvinyl chloride. Okay, here the monomer vinyl chloride is obtained by treating the acetylene with hydrochloric acid at 60 to 80 degrees in presence of metal chloride, that is zinc chloride as a catalyst. Zinc chloride as a catalyst. Okay, ma, we'll discuss this in the next class once again.